In this example, we're given the natural spring length at rest is 10 meters. The force of 4.5 newtons holds the spring stretched out to 10.5 meters. So from that position, from 10.5, we're going to find out how much work is needed to stretch it to 11 meters, starting at the 10.5 meter position. So our solution for this straightforward, moving in a straight line stretch is we're going to use the spring Hooke's law for the spring. And step one, we're going to use the initial condition that they gave us to find the constant K in Hooke's law, F equals K times X. So it's a constant. It's a value that relates to this particular spring with the material and the tension in that particular spring. So we replace force F with 4.5 equals K times the amount of stretch for the initial situation from 10 meters to 10.5. So we take the difference between those two, and that gives us 4.5 equals 0.5 times K. Solve for K. K equals 4.5 divided by 0.5. So K is equal to 9. And this constant applies to the spring in all situations. Since the newtons are measured, they're equivalent to kilograms meters per second squared, our K value is going to be equal to 9 newtons per meter, which simplifies to 9 kilogram meters per second squared times meters. The meters cancel. We get 9 kilograms per second squared. And our answer is K equals 9. Thus, the force to stretch the spring X units in general is F of X equals 9 times X. Instead of K times X, we have 9 times X. Right there. Okay, step 2. Now we're ready to find the work using that new refined version of Hooke's law, the formula for the force. So work is equal to the integral from x equals a to b of the force f of x dx. In this case, it's a spring, the force on the spring, so we have the integral from the starting position, x equals 10.5, to the ending position, 11, of the force, the spring force, 9 times x dx. The antiderivative of x is x squared over 2, so we have 9 times x squared over 2, evaluated from 10.5 to 11. So the work is 9 halves times 11 squared minus 10.5 squared, which is 9 halves times 121 minus 110.25, which is equal to 9 halves times 10.75. So our work is equal to 48.375, and the units for this is going to be joules. Now we are in the metric system instead of the British units, so the units for work is in joules.